Good morning, children. So, after a long time, we are meeting through online class. So, hope you all did well in quarterly examination. So, after your quarterly examination, we are starting the online class. And in physics, we are starting with the topic 3.82. We are discussing in unit 3 about magnetism. So, various thoughts, various discussions, various knowledges we discussed, we crossed. Now we are on topic number 3.8.2, magnetic field due to a long straight conductor which is carrying current. We all know what is called conductor. So conductor is nothing but the charges or the current or the heat is easily to flow. So like we can say for conductor, we can give the definitions like this. And in this we are using current carrying conductor. So as known aspect, whenever the electric current is flowing through the conductor, around that conductor it producing magnetic field. That is known fact. So using that fact, with the help of Biot-Savart law, we are going to give the famous and important derivation in this topic. So already we discussed about Biot-Savart law before your quarterly examination. You have to recall once. Okay, so that is base. I hope you all know about that. If you forget about that, just you go once and recall about that Biot-Savart law, because we are going to use that equation directly here. Using that only we are going to derive this equation. And the figure 3.32 is given. And before explaining about this figure, in this there is a mistake. Just refer with your book. And in this figure 3.32, A is there, no? You cut that A and you write the A here. So in B place you use A, and in A place you can use B. Please make this change in your book. Okay, so in A place you write B. Instead of B we are going to use A. Okay, this is a small mistake which is given in this figure. You refer with your book. And now there is an explanation for this figure 3.32. We are having current carrying conductor Y dash, which carrying with the current I, which is flowing from Y dash to Y. Then we are choosing the point O. In the conductor midpoint we are choose pannirukkom O, and from O we are selecting the point P in a distance A. Okay, in a distance A. And in this conductor நம்ம Biot-Savart law already தெரியும், நான் சொன்னேன், டிஸ்கஸ் பண்ணியிருக்கோன்னு சொன்னேன். அந்த Biot-Savart lawல கரண்ட் கேரிங் கண்டக்டர் எவ்வளோ மேக்னெட்டிக் ஃபீல்ட் ப்ரொடியூஸ் பண்ணுறதுன்னு தெரிஞ்சுக்கிறதுக்கு என்ன பண்ணுவோம்னா, ஒரு சின்ன செக்மெண்ட்டை செலக்ட் பண்ணிக்கிட்டு அந்த செக்மெண்ட் எவ்வளோ மேக்னெட்டிக் ஃபீல்டை ப்ரொடியூஸ் பண்ணுதோ அதை we will expand throughout the conductor using the integration method. The same way we are following here. இங்கே எதை நம்ம சூஸ் பண்ணியிருக்கோம்னா this region. நான் சொன்னேன்ல, பிஐ ஏவாவும் ஏவை பியாவும் மாற்றிக்கிட்டு அந்த ரீஜன் மட்டும் we are choosing. That AB is called a small segment which having the length DL. இப்போ பியிலிருந்து நம்ம சூஸ் பண்ண பி பாயிண்ட்டுக்கு ஒரு லைன் நம்ம ட்ரா பண்ணுறோம், தட் இஸ் பிபி. அண்ட் ஏலிருந்து ஒரு லைன் பிக்கு நம்ம ட்ரா பண்ணுறோம், தட் இஸ் ஏபி. அண்ட் இட் கிவ்ஸ் த ட்ரையாங்கிள் ஏபிபி. அண்ட் இட் கிவ்ஸ் த ஆங்கிள் ஏபிபி is equal to d5. Clear? Yes, clear. And next, after joining this, we got another one triangle APO. இதில் APO angle is 5. இதுதான் 5 சொல்லுவோம். சர்க்கிள் போட்டு ஒரு லைன் போட்டு this is 5. APO is what? That is 5. Then we are joining Y dash to P and Y to P. Y dash, angle Y dash PO is 5.1. Angle YPO is 5.2. Then we are drawing from A towards the BP line is a perpendicular line. It gives 90-degree angle and it forms a new and small triangle ABC. In this angle B having the value theta. So all things are explained. This is about the diagram. Then we'll discuss how to derive this equation. Don't forget, இங்க bக்கு பதிலா நம்ம a யூஸ் பண்றோம். ஃபிகர்ல மிஸ்டேக் பண்ணிருக்கான். புக்ல செக் பண்ணிக்கோ. செக் பண்ணிட்டு if there is a mistake you change, you correct that. புக்ல கரெக்டா கொடுத்திருந்தா you can take as it is. Okay. So இப்போ நம்ம derivation part போறோம். And in this derivation first we are using the Biot-Savart law, and this is Biot-Savart law. இந்த equation எப்படி வந்துச்சுன்னா previous derivation இதுக்கு முன்னாடி சில டாபிக்ஸ் முன்னாடி நம்ம derive பண்ணியிருக்கோம். db vector is equal to mu naught by 4 pi I ds sin divided by r square n cap. So what it says is the magnetic induction produced by the current carrying conductor is directly proportional to electric current flowing through the conductor, directly proportional to length of the segment which we chose, an angle between the line of joining and extension of the small segment, and the magnetic induction is inversely proportional to square of the distance which we chose from the midpoint of segment to where we have to calculate square of the distance. And the equation தான் நம்ம எடுத்துக்கோம். b vector is equal to mu naught divided by 4 pi I ds sin divided by r square into n cap, and here n cap is vector and mu naught by 4 pi is nothing but constant. It is a constant term. இப்போ இந்த ஆன்சர் நம்ம என்ன பண்ண போறோம்னா இந்த டெரிவேஷன்ல y dash கண்டக்டரோட டோட்டல் இண்டக்ஷன் மேக்னெட்டிக் ஃபீல்ட் அட் த பாயிண்ட் p ல எவ்வளோ இருக்கும் அப்படின்றத நம்ம கால்குலேட் பண்ண போறோம். அதுக்கு தான் we chose a small segment. Got it, children? And we are expanding our derivation. We are applying the trigonometric in a triangle ABC. So where is the ABC triangle? This is the triangle ABC. Okay, கையில புக் வச்சுக்கோ. புக் வச்சு ரெஃபர் பண்ணி இந்த கிளாஸை நீ கவனிச்சோன்னா உனக்கு ஈஸியாக இருக்கும். So this is the triangle ABC. So in this triangle ABC we are going to apply the sin theta formula. So sin theta is nothing. What is sin theta? It is opposite by hypotenuse. In the triangle ABC we are writing the opposite, that is AC, and divided by AB. Okay, so actually this is A, no, this is not B, this is A, this is B. So what is opposite? Opposite is AC, and hypotenuse we wrote as AB. Okay, and then we are substituting we are expanding this equation as after this cross multiplication AC is equal to AB sin theta. And what is AB? AB is nothing but a small segment. What is the length of the DL? In diagram itself it is there. Then we are rewriting the equation. AC is equal to DL sin theta. Say this is one equation. And next we are taking the small angle d phi. D phi irukka triangle நம்ம எடுத்துக்க போறோம். Okay, so we know where is d phi. See the figure. This is the angle d phi. So triangle நம்ம BPA எடுத்துட்டாலும் okay, BPC எடுத்துட்டாலும் okay. Angle BPC is having the value of d phi, or we can write CPB இல்ல APB னு எடுத்துக்கலாம். You can take this no. So we are taking that is equal to d phi. Then we are using the triangle APC. So where is APC? So once more I am saying this is not B, this is A. So we are taking APC triangle, this triangle. This is B. Okay, are you clear? Yes, good children. So we are taking the triangle A, P and C. Okay, so using that we are writing the formula sin d phi is equal to opposite by hypotenuse AC by AP. And say the angle is very small, the d phi is very small, then we can write sin d phi as d phi. Many times we did this. Okay, in 11th many times we did this. The angle is very small means sin d phi can be written as d phi. And next we are writing AP, we know very well, it is given in diagram itself, that is equal to R. Then we can write the same equation. AC is equal to, AP will goes left hand side, then the equation we can write as AP sin d phi. Okay, and d phi sin d phi is taken as what? D phi. Then AP into d phi will come. AP is equal to R. Then we can write R d phi. So what is AC is equal to R d phi? And here AC is equal to I ds sin theta. Then we are comparing these two equations. So we are comparing these two equations. After comparison we are writing the equation as AC is equal to dl sin theta is equal to r d phi. So this equation comes after comparing with these two equations. AC is equal to r d phi and here AC is equal to dl sin theta. Then we are equating the right hand side. Then we can write AC is equal to dl sin theta is equal to r d phi. Okay, then we are substituting this in the previous equation. dB vector is equal to mu naught divided by 4 pi I r d phi divided by r square into n cap. Then we are altering the equation. We can cancel this r square and r. Then equation will become mu naught divided by 4 pi I d phi divided by r n cap. And phi be the angle between, we know in diagram it's explained. Then we are choosing the triangle OPA. Okay, so once again I am reminding you, this is not B. This B will be taken as what? A. We are taking what triangle now? OPA triangle. So in this OPA triangle, we are giving the derivation here for OPA. Cos phi is equal to, we are taken as OP by BP. So what we are taken? OP by BP. Then we can substitute. OP is given in figure. It is nothing but A. And what is BP? BP is written as R. Then after cross multiplication, R will become equal to A divided by cos phi. So in this cross multiplication, after this equation, we are getting this term R is equal to A divided by cos phi. Then we are substituting this R in this equation. So dB vector is equal to mu naught divided by 4 pi is there. I, we are substituting the value for R. A by cos phi. This cos phi will goes up. Then the equation will become dB vector is equal to mu naught I divided by 4 pi A cos phi d phi into n cap. Okay, and this is what, this equation is for only the small segment. This equation is for only this small segment AB. In the AB க்கு மட்டும் தான் நம்ம இப்போ calculate பண்ணியிருக்கோம். That is the equation we got now. So we have to calculate for throughout the conductor. அப்போ என்ன பண்ணுவோம்? We can use the integration. For throughout the conductor, we are using the formula here. For only the small segment, we use the term dB because it is small. For throughout the conductor, we can write the same dB as B vector. Then we are using integration. Then the integration value starts from phi 1. It is taken as negative. This is phi 1. This area is taken as negative and phi 2 is taken as positive. We are applying as limitation. Then we are getting the answer. So integration minus phi 1 to phi 2 mu naught I divided by 4 pi A. This is from this equation. Mu naught I divided by 4 pi A cos phi d phi into n cap. Then you take out the common. Mu naught I divided by 4 pi A, that is constant for this equation. The integration cos phi d phi will become sin phi. Then integration limits we are applying minus phi 1 to phi 2 n cap. And after substituting that, we are writing the equation B vector is equal to mu naught I divided by 4 pi A sin of phi 1 plus sin phi 2 n cap. About the integration substitution of limits, you know very well, we discussed in many cases in 11th standard. Suppose if we are choosing the conductor, here we used conductor now y dash. If it is infinite long means the phi 1 and phi 2 value will be expands. The given phi 1 value and phi 2, suppose the length is increases, for infinite length means this phi will be increases. It will be increases. This also will be increases. If it is infinite means we can write this value can be taken as for 90 degree. It will be expand up to 90 degree for infinite length. Then we are substituting the limitations of phi 1 and phi 2 as 90 degree. Then here we are substituting. So mu naught I divided by 4 pi A into sin 90 is 1 plus sin 90 is another 1. Then 1 plus 1 will become 2 here. Okay, and the equation will become mu naught I divided by 4 pi A 2 n cap. Then when we are cancelling this 2 and 4, the answer will become mu naught I divided by 2 pi A n cap. This is equation 3.36, and this is the value for infinite length of the conductor which is offering the magnetic field that we obtained with the help of small segment. Using the small segment, it is expanded with the help of integration. The expanded formula is mu naught I divided by 2 pi A n cap. If we know I, A value means we can find out how much magnetic field will be produced by the current carrying infinite length of the conductor. This is the formula for that. We done here with the help of the figure 3.32. So this is very most important question answer, children. Please mark this answer from here. Okay, the whole topic from the diagram figure 3.32, and don't forget, refer with your book. This is not B, have to write with A. This is B. Okay, so in A place it should be written as B, then B place should be replaced by A. Okay, there is a mistake in this diagram, and this answer will be extends up to next page before the topic 3.8.3 up to the equation 3.36. This is most important question answer, and write question here, explain here, write your question. Obtain an expression for magnetic field due to long straight current carrying conductor. Okay, this is most important question, and you take this only one question as today's homework, and you thorough this answer. After thoroughing that, you write this answer in your homework note page without seeing this answer. This is most important. You thorough this. Okay, and after following this answer, some topics will be based on this derivation. So next we will discuss about coil. So how we discussed here for straight line conductor, like that next we will see for coil. So current carrying coil means it having the circular coil. So what is the magnetic field produced by that? We will discuss in next class. Thank you, children.